Students, good morning to all of you. Students, our today's topic is compound microscope. In the previous class, we would done or understood about the concept of magnifying power of magnifying glass. As we learned in the previous class, if an object which is in front of a magnifying glass and placed in between its focus and optical center, then it would form a larger image. It would form a large image than object. Okay, and we will discuss about what is the formula for magnifying power for this, which is equal to 1 plus d upon m. This is the formula for magnifying power for a case when object is in between focal length and the optical center of a lens or a magnifying glass. Then it would form an erect and virtual image for the object. Okay, so we are using the same procedure in the compound microscope, and here we are using two biconvex or magnifying glass. One is called O lens, called objective lens, and another is E lens, I lens. Now, according to their name, because of the objective lens is near to the object and eye lens is near to the observer. Okay. Now, an object which is first condition is, as we know, the object which is placed in between center of curvature and the focal length, the image formed by the convex lens is inverted and real and larger in size. Okay. So, a light which is traveling or a ray which is traveling parallel to the principal axis of the objective lens is passing from its focal length. Okay, and another ray which is passing from its optical center is intersecting at point E dash. Clear? And when we draw a perpendicular on the principal axis of these two coaxial lenses, then we get the location of B dash. Hence, this A dash, B dash is the image of the object, and it is very clear that image is formed in between the focal length of eyepiece and the optical center. That is, now it can form a virtual and magnified image of A dash B dash, because this A dash B dash behave for eyepiece as an object and it will form its image. Okay, now let a light which is coming from optical center is moving in this direction, and a light which is coming from its focal this one which is parallel to it is traveling in this direction and it forms a magnified image at this location. Okay, so this is A double dash B double dash, the final image formed by eyepiece of given object. Clear? Now, here we find Suppose there is an observer and all the rays are entering in his eyes. Therefore, the angle first the angle formed by the object on the eye is alpha. Okay, now if we increase or drop incident ray, then let this is an index which is equal to the size of object, and from here this is angle formed by object on eye called alpha, and this is a ray which is traveling from the object and center of curvature. So this is the angle formed by by image on eye. This angle is beta. Okay, and in the previous class we discussed that the magnifying power of a magnifying glass is the ratio of the angle formed by image on eye to the angle formed by object on eye. Here we can define the magnifying power of a compound microscope is the angle subtended by final image on eye to the angle subtended by object on eye. Clear? So angle subtended by final image on eye, that is beta to angle subtended by object on eye is alpha. Therefore, magnifying power of compound microscope is beta upon alpha. This is equation first. Okay. Now, magnification of objective. What is the value of magnification produced by objective? So answer is distance of image to distance of object. Okay, or simply we can also say A dash B dash upon AB. Okay, and magnification of eyepiece is object for eyepiece is A dash B dash and image formed by it is A double dash B double dash, which is A double dash B double dash upon A dash B dash. Okay, now as we discussed, okay, as we discussed at the time of combination of glasses, the magnifying power, the combined or combination, magnifying power of combination is product of the magnifying power of the each lens. That is, the magnifying power of compound microscope is MO into MP. Okay, therefore A double dash A dash B dash AB into A double dash B double dash upon A dash B dash. Okay, now we find that this will cancel to each other and magnifying power is A double dash B double dash upon AB, which is side of image, final image to side of object. Okay, now we can calculate the value of A dash B dash in the form of distances. See, if distance of object from objective lens is u0 and image formed by objective lens is v0, okay, and this is the distance of object for eyepiece is ue and this is the distance of final image VE from the eyepiece. Therefore, in triangle L and C2. 1 minute. Yes. M and C2. Okay, we get this is tan alpha, or we say alpha is equal to tan alpha is equal to L and upon and C2. Okay, and C2. Here also we take some adjunction. C1 B dash is equal to and C2, that is equal to VO. It is clear? The distance of object from C1 to B dash is equal to N dash C2, which is equal to V0, image formed by the objective. Second, yes, and N dash is equal to AB as per geometry, side of opposite side of rectangle. Okay, now alpha we get from here AB upon C1 B dash is equal to AB upon u0. Okay, and beta is equal to this. We take the triangle, this one. Okay, so A double dash B double dash upon 1 minute. It is okay, or either we yes 1 minute. This is not required to done here because we need to use the magnifying powers. Okay, so what is MO? MO is height, distance of image, that is V naught upon distance of object, which is U naught, and in front of object, so it is minus U naught. Okay, and magnification produced by eyepiece is distance of image to distance of object, which is minus VE upon minus UE. This is cancelled and we get the result is VE upon UE. Okay, and because object is in between focal length and the center of curvature, so we can put here for eyepiece 1 upon Fe is equal to 1 upon Ve minus 1 upon Ue. Clear? By taking Ve as common. Okay? One upon Ve as common, we get 1 minus Ve upon Ue. Clear? This Ve multiply here 1 upon Fe. So you will get from here is Ve upon Fe is equal to 1 minus Ve Ue, and calculate the value of Ve upon Ue. What you get from here? That Ve upon Ue is equal to 1 minus Ve upon Fe. Clear? Now, if Ve is equal to minus D is least distance of clear vision. Therefore, we get Ve upon Ue is equal to 1 plus D upon Fe. It is clear or not? By using this value here, we get magnification produced by eyepiece is 1 plus D upon Fe. This is the magnification produced by eyepiece. Therefore, final formula for the magnification produced by eye or compound microscope M naught into ME. By putting this value, we get V naught upon U naught and 1 plus D upon Fe. This is formula for compound microscope for image formed at a finite distance or least distance for clear vision. Here we can also use a mode, that is M is equal to V naught upon mod of minus U naught 1 plus D upon Fe. Okay? Now, you can also calculate V naught upon U naught in the form of focal length of objective lens by using the same rule. Okay? That you get M is equal to 1 plus 1 minus V naught upon F naught and 1 plus d upon f. Okay, this is the another formula for the magnifying power of compound microscope. So it okay, and if the image formed at infinity, then we get the result. See, if the image formed at infinity, so this okay. If image formed at infinity, therefore magnification produced by objective is the same V naught upon minus Q naught, but the magnification produced by eyepiece is D upon Fe only. Okay, therefore magnification of compound interest when the image formed at infinity is V naught minus U naught and D upon Ft, where D is least distance of clear image. Okay, as per arrangement of the compound microscope, L is the distance between C1 and C2, which means length of rod. Okay, therefore magnification produced by compound microscope is L upon minus U naught 1 plus D upon F. This is the another formula, and this can also be written as M is equal to, in place of V naught, which is equal to V naught. Okay, so we can also use L upon minus U naught in mod D upon Ft. This is the final formula for the compound microscope, and it is very most important.